Good afternoon, my dear student. So yesterday I discussed about different ideas of resistive welding. Okay, so I discussed about different types of resistive welding like bar welding, then flash welding, spot welding, then seam welding, and finally projection welding. Okay, that I have been discussed. So then we have discussed about the basic concept of the arc welding. So what is the importance of the arc welding? So basically what happened in case of arc welding, if you see the diagram, so again there is a that wax piece will be there. Okay, so your electron holder is there. Here you can see that is there are two types of arc welding. One is your electric arc welding, another different weldings are there. So first one is your electric arc welding. Then in between of the electric arc welding there are different types of arc weldings are there. Like first started with the metallic arc welding, then carbon arc welding, atomic hydrogen welding, then shielded arc welding. Okay, so different methods are there. So here you know that that electrode holders are there. Okay, so what happens? So based on your electrode, you can select which type of arc welding you are going to be used. Okay, so what happens here? You can see that arcing will be there. Okay, so flames are there. It is flux coated electrode. So it is your holder, means electrode holder. So here it is your electrode. So workspace is here like a negative terminals. If you connect the transformer or generator negative terminal, so that's behaves like your zero potential, maybe you're nearer to the zero potential negative terminal. So now you are moving your holder. Okay, holdings here you are using, so you are moving your holder, and your electrodes are there. As the electrodes is moving, okay, so your holder is moving, electrode holder is moving, so your electrode also be moving, and flux coated electrodes is there, means with that holder it is also moving. Okay, so what happened after moving? So here you can see that it will be melting and coming to your workspace. Okay, so it is your flame. As your arcing is developed, so flame will be there. Okay, so due to the flame means arcing and the flame, so what happened? Your filler material, so that electrode is there, so it will be melting automatically and running just above of your workspace. Okay, so if it you whatever welding you are required, so that we can use. So it is globally, it's an metallic arc welding. You can see the diagram. So it is very globally acceptable welding processes. So normally we are using in our commercial purposes. Okay, so from here you can see what is the motivations of the arc welding. So you are using that, it's a definition is the electric arc welding. So what is the motivations for your electric arc welding? Basically you are using the electrical energy for providing or for developing the electric arc. Okay, based on that arc, what happened? Based on that arc means there is some potential difference. Okay, high voltage potential difference. Okay, that will be in the kV range. Okay, so based on that high voltage potential difference, the huge voltage will be there, and that voltage may cause for melting down of your electrodes. Okay, so that electrodes definitely is most of the time we are using means some insulated electrodes. Okay, that insulated electrodes is called, who will provide that kinds of insulated electrodes? So that flux line. Okay, that is also known as flux. So what is the importance of the flux? That is written a flux coated. Here you know that flux coated electrode. So flux also providing there are two options. Okay, so flux also being providing to quick melting of your filler material. That is number one. Another second point is that when it will be welded, so there another the flux coating will be there. Okay, so flux coating means if the welding material is an filler material, so if you are getting any flux coating, so there is a chances, there is a reduction of chances of oxidations of your filler material with your air. So that's the purpose of the flux. Okay, so here, so you are using the electricity to producing that arc. That's the basic motivations of your electrical arc welding. Okay, so here electrical arc welding. So what is that system? So in which the metal is melted. Okay, the metal is melted by the heat of an electric arc. So you are provide the electric arc is developed, and due to that arc, so metal is melted. Okay, it can be done with the following methods. So there are different methods that I am telling first. So first one is that metallic arc welding. Okay, so metallic arc welding means you are using that that material. Okay, that filler materials is you are using, that's a metal, means electrode or is the metal. Okay, based on your electrode. Second one is the carbon arc welding. So electrode is your carbon. Okay, the electrode is prepared by the carbon. So third one is the atomic hydrogen welding. So you are using that hydrogen. Okay, so atomic hydrogen for this welding purpose. Last one is the shielded arc welding. So again it is TIG, MIG, different types of tungsten filament. Means what happens, some additional coating you are using, additional shielding you are using about means just before of your arc. Okay, so sorry, electrodes. Okay. So what happened here? So in metallic arc welding, so what is written? So a fairly short arc length is necessary. A fairly short arc length is necessary for getting the good welds. Okay, the short arc length permits the heat to be concentrated on the workspace. So you can see, so heat will be concentrated on the workspace. How it will be processed? So basically, your workspace electrode, that is your high voltage potential. So there is a potential difference in between your electrodes and the workspace. Okay, so if there is a difference, so sometimes what happens, due to the high potential difference, so arc will be developed. Due to the arc, heat will be developed. Due to the heat, it will be melting down. Okay, and current will be passing through that medium. Okay, is more suitable because the effect of magnetic blow, okay, effect of magnetic blow is reduced, and the vapor from the arc surrounded the electrodes metal and the molten pool, thereby the preventing the air from the destroying the weld metal. Okay, so you are using that preventing molten pool, you are using for sorry, so you are, what about that arc surrounded with the electrode material, okay, electrode metal and the molten pool, thereby the preventing the air from the destroying the weld metal. So on coating will be there that can prevent that can prevent the destructions of your workspace also. That is another features is you can observe here. Okay, the length of the arc required for the welding depends upon few factors. First one is the electrodes, what kinds of electrodes you are using, what is the coating of the electrodes and the diameter of the electrode. Second point is the position of the welding. So from where you are welded that thing, amount of the current. Okay, so which amount of current is passing through that. Okay. Third one is here, usually the shorter arc length is necessary for vertical and horizontal and overhead heat welding for the flat welding. Okay, so what kinds of the shorter arc? Okay, shorter arc means the arc length will be less. Okay, if it is more means that may cause for additional energy losses, and that if you see that arc length is more means additional extra high voltage is required, additional high voltage is required. So additional high voltage means additional energy is required. So try to make it a moderate, means shorter length of your arc. Okay, the deflections, what happened, the deflections of the arc from the weld point is called that arc blow. Okay, so that arc is coming back to that is called arc blow. This conditions is encountered only with the DC welding sets and especially noticeable when the welding with bare electrodes. Okay, so bare electrodes, normally there are two types of electrodes. Those are very expert about the welding, so they are using the bare electrodes. But bare electrodes, there is a chances of a shock. Okay, so if you don't have any kinds of experience about this work, so you should not use that bare electrode. So you have to go for that flux coated or insulated electrodes. Okay, for the preventions. Okay, but what happened, definitely flux coated electrodes will be more costlier than your bare electrodes. The experts, that welding experts, they are normally using the bare electrodes for our commercial purpose. Okay. means not so expensive one. It is expensive. It is expensive most when the current is above 200 ampere or below 440 amperes. Okay, so you have to make it in moderate region in between 40 to 200 ampere. Okay, due to arc blow, that is called arc blow, what heat penetrations is required to area is low with the leads to incomplete fusions. Okay, and the main porosity apart from the excessive weld spatter. Okay, so the arc flow can be avoided by using AC rather than the DC welding machine, because the reversing current in the welding leads produce the magnetic field which cancel each other out, thereby eliminating the arc flow. Okay, that's the basic concept, so we can follow with that one. So for that welding purpose, okay, so that is your basic concept of the electric arc welding. Then we are using that metallic arc welding. So I have already told you what is the purpose of the metallic arc welding, the same thing. So what are the important features of the metallic arc welding? So first features is that metallic arc welding is an arc that established between the work and the filler material. So that's a very common part, basically that is your electrode. So simple thing is that the instead, okay, the incense heat the arc from the molten pool in the metal being welded. Okay, so you are using the molten pool for the welding purpose. At the same time melts the tip of the electrodes. So tip of the electrodes are melting. Okay, as the arc is maintained, the molten filler material from the electrode tip is transferred across the arc where it fuses with the molten base metal. Okay, so there is a chances of the fuses of the molten base metal. Here you know that lead clamped to the work. Okay, the arc may be formed with the direct and alternating current. The petrol or the diesel driven generator are widely used for the welding in open, where the normal electricity supply may not be available. Some site is there in the industrial area, so directly you have to work some remote areas, the electricity is not there. So how do you get that energy? So you have to based on the generator. Okay, so the generator means so that chemical energy directly converted to the electrical energy. So diesel generator like that thing. So in that case, high voltage is provided by the generator. If it is available in our normal plant, so electricity, so you can directly use on it. Basically for that welding purpose, high electrical energy means you can see the lot of current, huge current is drawing na? So 200 ampere, 40 ampere to 200 ampere. So system should have the separate connections. Okay, normal distribution system you cannot add with your welding, so that's why the special transformer is required for it. Okay, so for providing a huge amount of current. Okay, voltage is less means it will be shorted na. When melting will happen means arcing will be there, so voltage is zero. Okay, means last class I discussed about voltage is very less value, 2 to 6 volt, but the current is very high. Okay, so what happens? So you can understand the power conversions. Okay, V into I, so that rating, VA rating also been decided by that way. Okay, voltage is less, maybe shorted, but a huge current will be flowing. Basically, a high voltage is providing. Okay, so DC may also be obtained from the electricity main through the instrumentally the transformer and the rectifier. So sometimes rectifications also be there if you are providing the DC, high voltage DC. So that rectifier is required, transformer and rectifier both are required. The simple transformer is however the widely employed for the AC, but in case of DC the transformer will not be required. So after getting extra high voltage, so you have to convert it to DC. So how do you make it DC? So rectifier, which okay, power electronics rectifier you can use. Okay, mood diode you can use. Okay, the transformer states are the cheaper and the simple, having no maintenance cost as there is no moving part. Okay, where with the arc system the cover or the coating of the electrodes normally used, but the DC system of for the cast iron and the non-ferrous metal base electrodes can be used in order to strike the arc is an open circuited voltage between 60 to 70 volt in required. Okay, so that all are the important features. Then we are thinking about the maintaining the short arc, that is 17 to 25 volts are necessary. Okay, so voltage drop across the arc is here 17 to 25 volt. The current required is 10 ampere to 500 ampere. Okay, so you can understand the values of the current is 10 to 500 ampere depending upon the class of the work to be welded. The great disadvantage, okay, the disadvantage entirely the DC welding is the presence of the arc blow distorted the arc stream from the intended part owing to magnetic force of the non-uniform magnetic field. There is a chances of the non-uniform magnetic field. With the AC arc blow is considerably reduced and use the higher current, the large electrodes may be restored to the enhance the rate of the weld productions. Okay, so I think all of you are able to get that point. So what they have want to discuss. Okay, so another important point is that the field of the applications of the metallic arc welding includes. Okay, so what are the most important field? That low carbon steel. Okay, mainly low carbon steel and the high alloy authentic stainless steel. Okay, that is normally used. Other steels like low and medium alloy steels can however be welded by this system by many precautions need to be taken produce the ductile joints. Okay, these all are the very important features of the welding. Okay, I think you are able to understand what are the important features of the metallic welding. Then here we are using some discussions, okay, comparative discussion about the AC welding and the DC welding. What are the most important features among the AC and DC welding? So first one is that we have to think about the points. Okay, so serial number one. So point is based on the power consumptions. Okay, in terms of power consumption, so which one is costlier? So sorry, which one is lower? So AC welding is lower than your high power consumption you can observe in the DC welding. Okay, I think you are able to understand. Point number two, that arc stability. So stability of the arc. So in case of AC welding, arc is unstable. That's the disadvantage. Why it is unstable? So AC having positive as well as negative on. So somehow it will be also that arc nature also been alternating in nature. That's why it is unstable arc. But in case of DC welding, it will be the stable arc. So I think you can understand why it is the stable arc. Number three, point number three is the cost. Okay, cost. What is the cost? Cost is less in case of AC welding. So transformer is simply means it's not so cost effective instrument, so easily available. But in case of DC welding, the generator is required, then lot of power electronics converter is required. If you want to control power electronics converter, okay, AC to DC, so you have to use the SCR, that high voltage. Okay, so that may be costly compared to your normal thing. Okay, point number three, four, you know, that is weight. Okay, weight is light in case of AC welding and it's more heavy in case of DC welding. Okay, so five is the efficiency. Efficiency is high in case of AC and efficiency is low for the DC welding. Six, the operations. Okay, what kind of operation? It is noiseless operation and it is noisy operation, DC welding. Then suitability, which one is more suitable, that you can see. Suitability, that non-ferrous metal cannot be joined. Okay, so that is limitations. In case of DC, suitable for both ferrous and non-ferrous materials. Okay, first class I discussed about in the first class of my welding. So ferrous and non-ferrous concept was telling by me. So that also been applicable in the DC welding. Okay, but AC welding only non-ferrous. So 1.5, the electrodes, what kind of electrodes is used? Only coated electrode, but DC bare electrodes are also be used. So welding the thin sections, okay, not preferred, but it is also preferred. The miscellaneous point, what is your miscellaneous point? What can be act as a cathode while the electrodes acts as a anode. Okay, so electrode is your anode and workpiece is your cathode. The in DC electrode is always negative and the workpiece always be positive. Okay, so this thing you can understand. So you are giving the positive terminal of the DC generator to the transformer. After rectifications, it will be connected to the workspace in case of DC welding, and the negative terminal you are connected to the welding materials. Okay, so I'm sorry, that electrode material. Okay, I think all of you able to understand what are the most important features in between comparison in between your AC welding and DC welding. Okay, so that concept is there. Then you have to know the specifications. Okay, which one is the specifications? Okay, so specifications means what? What kinds of specification you can observe? That AC transformer. Okay, so basic one for the AC welding. DC generator is required for the DC welding. Okay, so AC welding space transformer it is should be step down, oil cooled. Okay, 3 phase 50 hertz. Current range is 50 to 400 ampere. Open circuited voltage 50 to 90 volt. That is based on your ranging. Okay, so it was there metallic welding, that is 17 to 25 volt. So that ranging, okay, 60 to 70 volt. Okay, 60 to 70 volt. Another is 70 to 25 volt. So based on that ranging, you have to provide the transformer open circuit voltage. Okay, energy consumption. So that is kilowatt hour. Okay, that is your unit. Okay, integrating factor, energy consumptions. Okay, 4 unit. 1 kilowatt hour means 1 unit. 4 kilowatt hour means 4 unit per kg of the metal deposit. Okay, then power factor is 0.4, efficiency is 85%. Power factor is not so good. Okay, so that's another problem. Okay, so in case of welding system. So in case of DC welding, the DC generator is there. What is the specifications? Motor generated 3 phase 50 hertz. Okay, current range is 150 25 to 600 ampere. Okay, current range is more high comparatively in your AC welding. So why it is high? AC resistance is more than of your DC resistance. Okay, 1.5 times more about. Why? Basically due to the skin effect. Okay, so AC resistance is comparatively more than your DC resistance. So basically that's why flux distribution is uneven in case of AC. Okay, but in case of DC it will be even. So current rating also be high for that one, for DC. Open circuit voltage, current is high, so open circuit voltage comparatively less of your DC welding. Basically power if you maintain to fix. Okay, so voltage is 30 to 80 and arc voltage is 20 to 40. Energy consumption 6 to 10 kilowatt hour. So definitely energy consumption also been more. Basically current is more means more energy. Okay, to deposit. So power factor again it having not so good, 0.4, efficiency 60%. Okay, so you can see in terms of efficiency, AC transformer, AC welding is much more convenient than your DC welding. Okay, that is better. Okay, so that kinds of options we can see from here. Okay. Now based on the positions of the welding, so it can be segregated in different positions. Okay, so from how that welding is being done. So here you can see 4 types of positions are there: flat positions, horizontal positions. Okay, that how the welding is there. Then vertical positions, you know that vertically, and finally overhead positions. Okay, so horizontal position and vertical position, simple thing to understand. It is in x-axis, it is in y-axis. Okay, welding. So what are the most important features? The following are the 4 basic positions of the manual arc welding done. So manually if you done for that arc welding, so these 4 are the very basic features. Okay, very means common things. Okay, so first one is your flat positions. Okay, flat positions. Second one is your horizontal positions. Third is your vertical positions and your overhead positions. So you can see the corresponding diagram. And what is this inside of that one? That is weld beds. Okay, weld bed. So where the welding is happened. So it is quite inclined. You can see that it is called workpiece. Okay, that white portion it is called workpiece. Okay, that is quite tilted. Okay, and you have done the welding in between of 2 workspace. Okay, so first one is your flat positions. In flat position, the flat positions is the easiest and most economical and the most used for all shielded arc welding. Okay, most simple and most easiest. With the bed, weld bed is exceedingly okay. Weld bed is exceedingly smooth and free of the slag spots. Okay, so it is simple and most economical. There is not very smooth. There is no uneven point or uneven spots are there. Okay, it provides the strongest weld joint. Okay, that weld joint is very strongest. This position is most adaptable for welding of both ferrous and non-ferrous metal, particularly for the cast iron. So, okay, so here you can understand that one. Okay, horizontal means you can see directly you have given that welding means in x-axis. Okay, in the dimension of x-axis, but it is not properly x-axis, some inclined thing you can see. Okay, then horizontal positions. Okay, what happened? This position is the second most popular. So first easiest and most economic, second most popular. Also they require the short arc length. Okay, arc length is shorted. It helps the preventing the molten puddle of the metal from the sagging. Okay, so sagging means it is you know that our system sagging means it is round up. Okay, so that is not there. Okay, preventing the sagging, molten paddle means molting filler material is not sagging by this method, but here the chances of sagging is there. That's why second one. While the welding is horizontal position, the major error is occur are undercutting. Okay, undercutting and the overlapping of the weld zone. So there is a chances of overlapping of weld zone. Means one welding is there, again there is a weld zone. Means you can visualize. Okay, your eye length you can go that welding. Then what happened? There is a, if you filler material is there. Okay, so filler material the chances to means coming to as per the gravity, what happened? Its chances to come back to the side of your just side of your metals bodies. No? So coming to the gravity. Okay, to a downwards. That's the difficult one. So that's why it is overlapping chances are there in horizontal position. Now vertical position. Okay, again in vertical position is difficult, na? So again all the welding material means try to go to the vertically downward. Okay, through the gravity. So here the more sedimentation. Okay, more concentration. The welding filler material concentration is more to the back side, means just nearer to the gravity. Then gradually the density is less. Okay, so that is quite difficult. Okay, the vertical position, what happened? In this position, the welder can deposit the bed either in uphill or the downhill direction. So uphill or downhill direction. Uphill means you have to go welding starting from that point, that is uphill, then come toward the downhill position. Okay, uphill welding is suited for the thickness of the metal because it produces stronger weld. Okay, so you have to start it from uphill position, otherwise there is not chances of that not good welding. Okay, the downhill welding is the preferred for the thin metal. Okay, because it is faster than the half hill welding. Okay, so it is faster than half hill welding. Okay, I think all of you will to understand. Then overhead welding, so it is here beyond the eye position. Okay, that is too difficult. The overhead welding positions means it in this position the welder has to very high cautious, otherwise he or she may get burned to drop the filler material. You know, you can understand. So it is in beyond the height. Okay, beyond your eye level, so there is a chances to coming back that filler material to the welder. Okay, this position is thought to be the most dangerous but not most difficult one. So definitely dangerous but not so difficult one. I think all of you can understand what are the different types of welding positions. Okay, based on the positions you can categorize them. Okay, then that type of welding means we have to think about the electrodes. Here you can see the diagram of the electrode. So it is your electrode. So electrode having internal core. Okay, so it is your internal core. Okay, so yeah, that internal core. Then flux coating is there. Okay, that is core wire. So melting that filler material is there. Okay, so it will be if that heat will be developed. So filler material melting over there and it will be deposit to the means gaps of between the two welding face. Okay, that is flux coating. Flux coating is outside like a jacket. Okay, so length of that one is 30 to 20 to 30 millimeter. Bare and clean. Okay, it should be bare and clean. Okay. So what are the electrodes? Okay, so electrodes, and electrode is a filler material. Okay, solid filler material in the form of the wire or the rod. Okay, which is either bare or coated uniformly with the flux. Okay, as per IS, Indian standard or international standard. Okay, 814 1970. Okay, that is standard of 1970. The contact end of the electrodes, that figure is given. The left bare and the clean to the length is nearer to the 20 to 30 mm for inserting into the electrode holder. So that bare position is required for the holder. Okay, holder will be there to just put it down. Okay, so depending on the thickness of the flux coating, depending on the thickness of flux coating, the will be classified as follows. There are different classification. Number one, lightly dusted. Okay, lightly dusted or the dipped electrode. Number two, the semi coated or heavy coated electrodes. Okay, so two things are lightly dusted or deep electrode, heavy coated or heavily coated electrode. The following materials, okay, are commonly used for the coating. So which are the material? Titanium oxide that you are using, okay, coating purpose. Ferromagnetic manganese. Second, third one is silica or the flour. Okay, then asbestos, clay. Fourth one is the calcium carbide. Fifth, sixth one is the cellulose with the sodium silicate, often used to hold the ingredients together. Okay, the electrodes coating help improving the weld usually as under. Okay, the part of the coatings burns in the intense heat of the arc and the previous and the provides the gaseous shell, okay, around the arc with the prevents oxygen, nitrogen and the other impurities in at the moisture from the combining with the molten material cause the poor quality brittle weakened. Okay, so these are the basic features. Okay, features of the electrodes. Another important points are also be there. Another portions of that coating of the flux materials. Okay, melts and mixes. Okay, mixes with the impurities in the molten metal cause them the floats of the top of the weld where they cool it from the slag. Okay, slag means that molten flux. Okay, molten material. Okay, so it is also used for cooling down. The slag improves the bed quality by protecting it from the contaminating the contaminating effects to the atmosphere and causing it to cool down the more uniformly. Okay, it also helps in cooling the basic shape of the weld bed. Okay, these are the most important features. So what are the types of electrodes depends on the following factors. What are the electrodes you are using, that based on that features. The type of the metal to be welded. Okay, most important. Right? Second is the welding positions, which positions you are using, you are welding. The types of electric supply, AC or DC. Number 4 is the polarity of the welding machines. Okay, which type of polarity you are using on it. Okay, these are the 4 important factors. Then what are the advantages for coating of the electrodes? Okay, first one is that arc stabilizations. Okay, that is important portion. Some advantages, principal advantages are given. Since the coating contain the compounds of sodium and potassium, so it can provide you the stabilized arc. Number 2 is the impurities presence on the surface being welded at the flux away. Okay, slag is formed. Okay, slag is formed over the weld which protect it from the atmospheric contaminations, makes the cool uniformly, thereby reducing the chances of the brittleness, provide the smooth surface by reducing the ripples caused by the welding operation. So these are important features of the flux, so that can help you the cooling down of your molten materials as well as prevent it to oxidize with the atmospheric elements. Okay, like oxygen, chlorine. Okay, highly negative elements. Okay, then splintering of the metal during the welding as prevented. Okay, welding operations become faster due to increase of the melting rate. Okay, the coating makes it possible for the electrode to be used on the AC supply. Okay, so you're using the AC supply. Since the efficiency of all coated and covered electrodes is imparted by the dampness, these must away to be shorted in the dry place. Okay, in case of dampness, is suspected to suspect the electrodes would be the died from the few hours for the warm cabinet. Okay, so after that it will be taking from the diagram. Okay, so here you can see different types of joints. Okay, joints of the welding applicable. So single filler. Okay, so that is called single filler, that is double filler, two joints are there. Okay, that is single bevel. Okay, only point tip. It is double bevel. Okay, so two point tips are there, that is single J shapes. Okay, then it is double J type of thing, it is single filler. Okay, different single filler, double filler. Okay, so that it is L shape. Okay, so that is T shape, it is L shape, both the cases. Okay, that is T shape like that on double filler. So arc welding, what happened the welding machines, the following are the two general types of welding machines are there. One is DC welding machines that contains motor generator set, AC transformer with the rectifier, that is one. Another thing is that AC welding machines. Okay, that are the generator. So what are the most important joints? Joints are there, T joints, then corner joints. Number three is the edge joints. So first one is the T joints. Okay, the T joints, that all are the corner joints. Okay, so these all are the corner joints or L-shaped joints. Then edge joints, that is called edge joints. Okay, blade single filler with the edge joints, two edges are joined, double edged joint. Okay, double fillet. Then it is with one type of weld. Okay, then lap joints. Okay, so in between of them. Okay, so it is here lap joints, the diagram of the lap joints. Okay, so it is the flap and it is slot. So these all are the lap joints, and last one is the bar joints. Okay, so here you are going for square bar. Here you are feeling that welding material. It is square bar joint. It is single V bar joints. Only this position will be joint. Double V bar joints. Okay, then single bevel. So it is called bevel type. Okay, single and bevel joints. Then double bevel. Okay, both are the then single U type of bar joint, double U bar joint, single J bar joints, and double J bar joints. All are the different features of the joint. Okay, 9 types of welding. So one that is 3 joints are 6 type of welding. 1, 2, 3, 4, 5, 6. Corner joints are 2 types of welding. That is 1, 2. Okay. Then lap joints are 4 type of welding. That is lap joints. 1, 2, 3, 4. I think so. Then last one is that lap joints are 1, 2. Only some figures are given. So T, that is given. So T means it is double tilt. So both are same like that. Okay. Then bar joints are 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. These all are the figures of different types of joints available in the welding. So I think all of you will to understand till now. If you have any kinds of queries, you can ask me. Okay, so it's a very informative chapter. So I think you are able to understand. Okay, I think all of you are able to understand that there should not be any kinds of queries. If you have the queries, you can write it to your chat box. So I can see that queries and give the answer sometimes. Okay, I think all of you will to understand. So it's not a very complicated one. It is very simple one. So and basically it's based on that. This is basically it's an help on that means informative ideas. Okay, so we can think about it and we can implement it any of the cases at the time of exam. Maybe some short note type of questions, or sometimes maybe small numerical types of questions may come from the basis of the welding. Side by side you should prepare the class notes. Okay, class notes on the welding purpose. Okay, so you should follow that my lecture so that you can prepare your class note. Okay, whatever important portions are there. So most of the important portion I have touched. Okay, sometimes what happens, some of the small thing also some portions maybe overlooked from my side. This happens, so try to go through that portions also. If you faced any kinds of difficulty, you can personally ask me, you can WhatsApp me, so I can give I can clear your doubts sometimes on through online modes. Okay, okay, so thank you for listening. in many